Good morning to everyone. My name is Ramesh, Assistant Professor, Department of Commerce, Soundarya Institute of Management and Science, Bangalore. Now I am going to explain. Subject is Quantitative Analysis for Business Decision, Unit number 4, Measures of Dispersion. Under this topic is Quartile Deviation. This subject will come under the Bangalore University second semester BCom and second semester BBA courses. Now I am going to explain Quartile deviation, meaning, definitions, formula, how to solve the problems, and coefficient of quartile deviation in three different types of series of observation. Three different series of observation are integral series of observation, discrete series of observation, continuous series of observation. This topic is same like median. How we will study median in the previous unit, that is called measures of central tendency. The same procedure we are going to follow here. First we are going to study definition of quartile deviation. Quartile deviation is half of the difference between the first and third quartiles. Hence it is called semi-interquartile range. Any one of the unit we can take 1 kilometer, 1 meter, 1 centimeter, whatever the measurement we are taking, equally 4 parts if you divide, that is called quartiles, 4 parts. 2 parts if you divide, that is called median. 4 parts if you divide, it's called as quartile. In that 1/4 of the value, it is called as Q1 or lower quartile or first quartile. Q2 median. Third/4 of the values you can say it is called as upper quartile or Q3 or third quartile. Half of the values we can say it is called as median. So median concepts only we are going to study. The same way, what is the difference of the quartile deviation we are going to see here. Formula is Q3 minus Q1 divided by 2. It is called quartile deviation formula. Among the quartiles Q1, Q2 and Q3, we know very well Q2 is called as median. Q1 and Q3 we are going to study. Q1 it is called as first quartile or lower quartiles. Q3 is called as third quartile or upper quartiles. Q3 minus Q1 is called interquartile range and Q3 minus Q1 divided by 2 semi-interquartile range. Coefficient of quartile deviation. Formula is Q3 minus Q1 divided by Q3 plus Q1. What are the merits, advantages of quartile deviation? It is simple to understand and easy to calculate. Already I said here what we are going to study in quartile deviation, similar procedure of median. Previous unit what we studied, the same procedure only we are going to apply. Here, simple way to understand the quartile deviation and easy for the calculation. It is not affected by extreme values because range we seen that maximum value and minimum value will be considered, that is two extremes values, but in quartile deviation it is not required because it is a positional value. It can be calculated for data with open in classes because it is not able to close interval only, it's not possible. We can use for open end class interval also. Suppose upper limit and lower limit will not be mentioned even though we can able to find out quartile deviation, because quartile, it is a positional value. Demerits, it is not based on all items, it is based on two positional values, what is q1 and q3, and ignores the extreme 50% of the items. We will be ignored because we will be taking and considering of third quartile and first quartile, that is q3 and q1. It is not amenable for further mathematical treatment. We cannot able to use further mathematical calculation for testing of hypothesis or distributions. The quartile deviation will not be useful. It is affected by sampling fluctuations. There is one few places sampling fluctuation will be affected. So the reason this wide application is very less. Now we are going to solve how to solve the problem. It is a problem under the individual series of observation, or we can say ungrouped data. The given values we can recall the median of will be solved. First we'll arrange in the ascending order, then we'll find out how many values are given. The given values are odd number, there is one formula. The given values are even number, even that is another formula will be used. Given values are odd means n plus 1 divided by 2 term. Given values are even means n by 2 term. Here the same procedure will be followed. Quartile deviation. Quartiles. Q1 means first fourth of the quartile. Q3 means third fourth of the quartile. So Q1 means 1/4 of the value. Q3 means 3/4 of the value. If we keep in this mind, then we will understand how to solve this kind of problem. First we need to arrange ascending order. Need to arrange data in ascending order to find Q3 and Q1 and avoid any duplicates. That means repetition, if it is there also, we need to be considered. So the given values will be written in the ascending order: 7, 11, 12, 13, 14, 15, 16, 18, 22. Total values are 9 values. It is a odd number. So the formula is Q1 equal to 1/4 of the n plus 1th term. We know very well it is an odd number, n plus 1. There will be 2 divided by 2 used. Here 4 because 1/4 the value. Or we can say first quartile, it is Q1. Q1 equal to 1/4 of the n plus 1. Q3 means 3/4 of the n plus 1th term. Substitute the n values. 9 plus 1 divided by 4. Then we can say 1/4 of 10th term. So we can simplify that 2.5. This value lies between 2 and 3. Which one? 2.5. So we will consider second term and third term. What is second term? 11. Third term is 12. So we can use that format. Q1 equal to second term plus 1/4 of the third term and second term difference. Why you have taken here? Because 2.5 lies between 2 and 3. Suppose 3.5 is there, we need to consider 3 and 4. Okay, this is the way we need to remember what is the value you are getting. This is the formula for Q1 in individual series of observation. So 11, second term value is 11 plus 1/4 of third term is 12 minus second term is 11. Simplify, you will get 11 plus 1/4 of the 1. So then we can simplify 11 plus 0.25. So we will get 11.25. This is called Q1 value. In similar way, Q3 value also we can find out. Calculation can be done. Q3 equal to 3/4 of the n plus 1th term. So n value 9, substitute and simplify. 3/4 of 10th term. Here 7.5. Already explained the Q1. 7.5, it is lies between 7 and 8. So 7th term plus 3/4 of, where that values 8th term minus 7th term, where 7th term is 16. Arranging in the ascending order, value count and take, and then 8th term is 18, and then 7th term is 16. So substitute 16 plus 3/4 of the 18 minus 16. Q3 equal to 16 plus 1.5, because 18 minus 16 is 2. 2 into 3, 6. 6 divided by 4, 1.5. So Q3 equal to 17.5. In this way Q3 will be calculated. Already we calculated Q1. Now Q3, both we are going to use for finding quartile deviation. Quartile deviation equal to Q3 minus Q1 divided by 2. Formula 17.5 minus 11.25. 17.5 Q3, 11.25 is Q1 divided by 2. 6.25 divided by 2. Simplify, will get QD equal to 3.125. This is the way quartile deviation will be calculated. Now we know very well each thing will find out coefficient. This value, that is QD equal to 3.125, is a absolute measure. Now relative measure will be find out. Coefficient of quartile deviation. The formula is Q3 minus Q1 divided by Q3 plus Q1. Q3 value 17.5 minus 11.25 will get 6.25. Numerator simplify. Then similar way denominator 17.5 plus 11.25 will get 28.75. Simplify, 0.21739. I will get 6.25 divided by 28.75. In this way we can able to find out coefficient of quartile deviation. Calculate the quartile deviation. Another example I have taken. Problem. First we need to arrange in the ascending order. Here n equal to 10 values, even value, so we can find out even formula. Arranging the given values in the ascending order: 140, 145, 150, 155, 156, 169, 175, 177, 188, 190. So Q1 formula we know very well. Q1 equal to 1/4 of nth term. Here n is 10, so we'll get 1/4 of 10th. So we know very well it is a 2.5. So 2.5 is lies between 2 and 3. So second term and third term will be considered. Second term is 145, third term is 150. So we can apply in this formula. Second term plus 1/4 of the third term minus second term. So substitute in this 145 plus 1/4 of 150 minus 145. 150 minus 145, 5. 5 divided by 4, 1.25. So 145 plus 1.25 equal to 146.25. Then Q1 equal to 146.25. The values we can find out. Similar way we will find out Q3 also. Q3 formula is 3/4 of nth term. 3/4 of the nth term is, we'll get 7.5. 7.5 lies between 7 and 8. 7th term plus 3/4 of 8th term minus 7th term. Here 7th term is 175, 8th term is 177. We can substitute in this formula 175 plus 3/4 of 177 minus 175. So we'll get 175 plus 1.5. So 176.5. Q3 equal to 176.5. Then we can find out quartile deviation. Formula is Q3 minus Q1 divided by 2. So Q3 value 176.5, Q1 value 146.25 divided by 2. So 30.25 divided by 2, 15.125. In this way we can able to find out quartile deviation. Then we can, this value is called as absolute measure, then relative measure will be finding. Relative measure is called as coefficient of quartile deviation. Q3 minus Q1 divided by Q3 plus Q1 is a formula. Substitute 176.5 minus 146.25 divided by 176.5 plus 146.25. So simplification will get 30.25 divided by 322.75. Then simplify will get 0.0937. It is a coefficient of quartile deviation. Then another problem will be considered. The given observation here is 15. First step we need to be arranged in ascending order. Will be written in the given values in the ascending order. It's already is given in the problem itself is called a ascending order. So we no need to arrange, as it is will be written. N equal to 15. 15 is the odd number. So we can follow odd number formula, 1/4 of n plus 1 term. 1/4 of 15 plus 1 will get 16th term. 1/4 of the 16th term is 4th term. 4th term here 21. So Q1 will get as the 21 is the number. Then Q3 will be finding. Q3 can be finding here. So n will be 15 plus 1. 3/4 of that 15 plus 1 is 16. So we will get 12th term. Here is a 12th term. In the ascending order is 30. Now we can find out quartile deviation. Formula is Q3 minus Q1 divided by 2. So Q3 is 30, Q1 is 21. Simplify, we will get 9 by 2. Then simplify 4.5. It is called quartile deviation. Now we can find out coefficient of quartile deviation. This is absolute value. Next, relative value. Q3 minus Q1, 30 minus 21 divided by 30 plus 21, 9 by 51. Simplify 0.1764. This is the way we can find out individual series of observation, quartile deviation and its coefficient. Now I am going to explain your discrete series of observation. The given values are like in this format. X and F it is there. We can find out. Solution. The given values can be written in the vertical form. Then we know very well here it is the concept applying for median method. So here we need to be find out CF, cumulative frequency. See that? So 4 will be written, 9 plus 4 13, 17 plus 13 30, 40 plus 30 70, 53 plus 70 123, 37 plus 123 160, 24 plus 160 184, 116 plus 184 200. In this way cumulative frequency we need to be finding. So total equal to 200. So cumulative frequency total also 200. Now Q1 equal to 1/4 of n plus capital N plus 1. Capital N here is 200. Here only one formula. So 1/4 of 200 plus 1 term. So simplify that. 201 divided by 4 will come. that is value is 50.25. The term where it lies, so it lies between 30 and 70. In that maximum is 70. So that one we can put the box here, Q1 equal to 16. This is the way we need to find. Then Q3 also can be found in this method. Q3 formula is 3/4 of n plus 1th term. Here n is 200 plus 1. 200 plus 1 is 201 divided by 3 times of 4. So you can see 150.25 term where it lies. This lies between 123 and 160. In that maximum is 160. For that x value is 24. So Q3 equal to 24. So this is the way we can find out Q1 and Q3 for discrete series of observation. Q3 minus Q1 divided by 2. Q3 value is 24. Q1 value is 16 divided by 2. 8 divided by 2. Quartile deviation is 4. Then coefficient of quartile deviation, Q3 minus Q1 divided by Q3 plus Q1. 24 minus 16 divided by 24 plus 16. Then 8 divided by 40, 0.2. This is the way coefficient of quartile deviation for discrete series we can able to find out. This is some of the problems is given for the practice.